Hello everyone, and welcome to the city of Radcliffe, which can be found on page 212. So our first problem has a fraction with a quadratic in the numerator and a quadratic in the denominator. So I am simply going to factor those two quadratics. So on the top, I need two numbers that multiply together to equal positive 9 and add together to equal negative 6. And the number that's going to work there is negative 3 and negative 3. And then on the bottom, I'm going to factor this, and I need two numbers which multiply together to equal positive 6, but add together to equal negative 5. And the answer is negative 3 and negative 2. So now that I've gotten this far, I get to cross some things off. So I'll cross a negative 3 in the numerator and a negative 3 in the denominator. And that leaves me with an answer of y minus 3 over y minus 2. And that is as far as I can factor that problem. All right, let's take a look at number 2. For number 2, we have 7 over 2xy squared minus 5 over 4xy. And so we are going to try to subtract those from each other, but we are going to need to have common denominators first. And so I can look at this because this is, these are small numbers, and I see that if I multiply this one by a 2y, and I have to do that on the top and the bottom, and if I multiply this one by just a y, then I should have common denominators. Let's see what I get. My top will be 7 times 2y, so that'll be 14y. And then my bottom is going to be 4xy to the third. Well, that doesn't seem right. Let's get rid of that. Let's get rid of that. Okay, so let's try this again. Let's multiply just by 2. So we get 14, and then we get 4xy squared. And over here, we will multiply by y, so we get 5y over 4xy squared. Oh, that looks nicer. All right, let's put it all into one fraction. So I have 14 minus 5y all over 4xy squared. And that is as far as we can go with that problem. So that is our final answer there. All right, let's do number 3. I think I'll get a new piece of paper just so I don't run out of room. Okay, so for number 3, we have 5 over z minus 3 equals 2 over z. Now, the way I'm going to do this one is through cross multiplication, because I like to do that whenever possible. So that's going to be 5z, that's when I multiply this way, equals 2 times z minus 3. So that will be 5z equals 2z minus 6. I will subtract 2z from this side. So I get 3z equals negative 6. I divide both sides by 3. Z equals negative 2. And that is the correct answer for z. Okay, let's try number 4. Number 4, we have Pat and Chris. And I forget what they're doing. What are they doing? They are, they're stuccoing over the hole. It would take Pat 5 hours to do this, and it would take Chris 7 hours to do this. And so the question is, how long would it take them if they worked together? So the formula that we're going to work with is going to be 1/5, that's Pat, plus 1/7, that's Chris, equals 1 over x. That's them together. All right, and let's calculate a magic number, please. Our magic number is going to have an x in it, And then it's going to be a number that both 5 and 7 can go into, which is 35 is the first one that I thought of. So now I'm going to take that magic number and I'm going to multiply it by all my numerators. So I'm going to wind up with 35x over 5 plus 35x over 7 equals 35x over x. And then when I reduce that, I'm going to get, let me see, 5 goes into 35 7 times, so this becomes 7x. 7 goes into 35 5 times, so this becomes 5x. And here my x's cancel, so I just get 35. 7x plus 5x will give me 12x equals 35. I divide both sides by 12, divide by 12, I get x equals 2 and 11/12 hours. So it will take them almost 3 hours to do it together. All right, let's take a look at number 5. Number 5 looks to be a little bit bigger and uglier than what we have done so far in this city. We have 5x over x plus 3. And we're going to add to that 15x minus 45 over x squared minus 9. Okay, so the first thing that I'm going to do is I'm going to factor this thing right here. And the reason that I'm going to do that first is because I'm eventually going to want common denominators here, and my common denominator is going to be easier to figure out if I do this. So that's what that is going to equal. That means that in order to have a common denominator, I need to multiply this fraction by x minus 3. That way I'll have x plus 3 times x minus 3 as my denominator. So let's just clean this up a little bit. So up on the top here we have 5x times x minus 3 over x plus 3 times x minus 3 plus 15x minus 45 over x plus 3 times x minus 3. All right, that looks a lot better. Let's put it all on one line and see what that gives us. And I think as long as I'm doing that, I'm going to go ahead and distribute this 5x because I'm going to eventually want that. So, distributing the 5x, I get 5x squared minus 15x plus 15x minus 45. And that is all over x plus 3 times x minus 3. All right, now I'm looking to see if I can simplify anything here, and I see that I have two like terms that are going to cancel each other out, right? A negative 15 and a positive 15 is just going to become 0. So now I have 5x squared minus 45 over x plus 3 times x minus 3. All right, so then my next step looks like in the numerator, I could suck out a 5. So I'm going to do that. Suck out a 5, so I get x squared minus 9, and that's going to be over x plus 3 times x minus 3. All right, now x squared minus 9 is a beautiful thing because those are perfect squares, minus sign in between. So that is going to factor to 5 times x plus 3 over x minus 3, and that is going to be over x plus 3 times x minus 3. We get to cancel out. Our answer is 5. Okay, let's do our next problem. Oh, I just needed to have a little swig of Diet Coke there so that I could go on. All right, I'll get a fresh piece of paper. Okay, number 6. we have x plus 3 over 8 equals x minus 2 over 3. And again, I'm going to do cross multiplying. So that is going to become 3 times x plus 3 equals 8 times x minus 2, right? I went across and then I went across. All right, so let's multiply it out. 3x plus 9 equals 8x minus 16. Let's get our x's all on one side, so I'll subtract 3x from each side. 9 equals 5x minus 16. Let's get rid of the 16 so we can start to get x by itself. 25 equals 5x. Divide by 5, divide by 5, x equals 5. So there we go. All right, so now the last question, number 7, is going to require a little bit of thinking about things. I think you can handle it though. It says that we have one job, and that takes 5 hours and 20 minutes. Okay, how much of the job gets accomplished in just 1 hour? How much gets done in 1 hour? Okay, so first thing I'm going to do is I'm going to convert 5 hours and 20 minutes to just hours. So 5 hours and 20 minutes, well, 20 minutes is 1/3 of an hour, right? So you could do 20, 20, 20. Okay, so 1/3 of an hour. So one job equals 5 1/3 hours. That way I don't have hours and minutes in the same problem. And then I'm going to convert that into an improper fraction. So 3 times 5 is 15 plus 1 is 16. So we have 16 over 3 hours. So if I say, all right, my one job, I'm going to divide that by 5 1/3 hours, or I'm going to divide it by 16 over 3. Then that would give me 1 times 3 over 16, right? Because you multiply by the reciprocal, which is just 3/16. So in 1 hour, 3/16 of the job gets done. And that is the answer to our question.